For the Inwerken group, our sponsors were Bastian Bachman and Maxim Reagan. And I'm Andrew Hannaford.
I'm Chris Buzaker.
I'm Nikolai Heiser.
And I'm Taylor Schmidt.
So our company that we worked for was Inwerken. They're headquartered in Hanover, Germany. They're founded in 1999, and they have more than 19 years of experience in consulting and software development. And they're a certified SAP partner. So kind of how I mentioned earlier, Inwerken is a SAP consulting firm. And that was one of our big software kind of sponsors for the project. And then we also had WSN, which was more of the hardware side of our project. And they're actually an Inwerken subsidiary. And they provided the gateway and the sensors that we used for this project.
And just to talk a little bit of what this project meant for why they needed this solution was their idea was to have a plug-and-play system for small to big, large companies in a way to keep track of their inventory, how long their inventory has been sitting, along with adding other sensors to keep track of temperature and humidity inside of the, like say, the warehouse or the production line where they have it, so that they can find faults within inside the building itself or with the actual product. This also had an implication of potentially using this data to then lead to automation of the warehouse that the technology currently sits in.
So a solution. This seems like a perfect thing to use IoT hardware and software for. This is where WSN, the hardware company, comes in. They created a gateway as well as proprietary sensors. These use LoRaWAN technology, long-range wireless area networks, and this is perfect for it because it is long-range. It, under the right circumstances, can last a mile, and it is very low resource dependent. The transmission of packets does not require a lot of energy, so the batteries and the sensors last a very long time. Additionally, a single gateway can manage a large number of sensors, so this makes it a cheap solution. So how we implemented this solution. All of the readings from each of the sensors are stored locally in a database on the gateway. This information is then displayed in a self-hosted single-page application. We used Angular. Now, why single-page application? Well, it pushes a lot of the processing or rendering power required onto the clients themselves. This makes sure that the gateway does not need to be extra beefy to display the page for a large number of clients that are connecting onto it. It can make sure that the gateway runs with a smaller processor. This makes data collection inexpensive and easy.
Schedule. During Sprint 1, we researched a lot of topics, including MQTT, Angular, and Node-RED. We had a little bit of issues with Node-RED because we weren't given the proper permissions, so that took a little bit of time to get sorted out. During Sprint 2, we worked on the backend and mockups. Mockups were a little bit tedious for us too because we couldn't agree on a platform with our sponsors to do mockups on. During Sprint 3, we did connections and we built the application base. We put CSS into it. We made it look pretty. And then during Sprint 4, we were continuing on the application and we were assigning sensors so that we could actually view the sensors and what they were assigned to.
So with the progress and status, we have the back end, which we have our SQLite server, our database that is set up to store all the inputs that we get from the sensors and for our application to pull the data from, along with our Node-RED flow, which is used to receive the JSON packets from the sensors, break them up, and then store it into the SQLite server database. Then we have our HTTP endpoints set up for connections along with we just have a whole bunch of connections set up between the application and the database within the application itself. For example, we have here's our just the schema of our database SQLite that's on the gateway, which is managed through our Node-RED flows. Which to show this is what our Node-RED flows look like. I mean, the whole intent of purpose is each of these are a function, and it takes an input, which would be the JSON packet from the sensor, break it up into a whole bunch of into all the different data pieces, and then puts the output out into a readable format for the SQLite's database. Interesting side note: these two big branches, for all intents and purposes, recreates a Node.js server. So, a lot of work.
Okay, now onto the front end. The front end, the application, it has pages for each of the features that Inwerken requested. The bulkiest of the page would be the analytics page. This lists the sensors and information about the sensors in a nice table, as well as displays readings from the sensors in a graph format. Also, there is a service page and assignment page as well. To demo this, this here is our home page. It's just got links and a little bit of information on what's on each page. If we go over to the service page, we can see contact information for both Inwerken as well as WSN. Bringing it on over to the analytics page, my roommate Will is at home right now. We've got the gateway running locally from my internet. It's a little bit difficult to set up here because of the restrictions with the NDSU internet. As you can see, it's got each of the sensors that we received, an ID for them, the type of data it stores, and their last reading. If we go to, you can choose which type of sensor to display. Currently, there are no sensors that have temperature or humidity, but it does offer support for that. So now that Will at home has been pressing the sensor, you can see that it will show the readings. Now this isn't particularly useful for the Kanban one. The Kanban sensors over there, thank you, Andrew. The Kanban sensor is used for inventory management. They will sit on a shelf, and it is either up or down. As you can see here, when there's a box on the shelf, it is pressed down, and it sends a signal that it's pressed and the shelf is full. And when it is up, that means the shelf is empty. There's nothing on top of it. It can also be used on conveyor belts or stuff like that for when it's rolling over, when things are rolling over it. This shows currently just the last hour, but it has information for each of the readings individually. This obviously will be more useful or a better display for things like humidity and temperature. You can see individually each sensor or an aggregate average displayed in a graph, which will make intuitively more sense than a 0 or 1 graph, but there are currently not sensors for that yet. Now if we go over to the assignment page, this is basically how the companies will be able to store and categorize each of their sensors. So let's say I have a warehouse, and this is going to be hierarchical, and so this one doesn't have any parents, and this one has no parents, and we confirm the creation. Okay, now I want to have floor 1. That will be in warehouse, and shelf 1. That will be in floor 1. Also, they can also have a second warehouse. Now, they can assign each of these sensors to whichever asset they want. So we currently, as the table showed, have 2 different sensors. We can take this sensor, assign it to shelf 1, and confirm. Now if we go over to assets and their sensors, warehouse, floor 1, shelf 1, it's right there. This was created this way to make sure that it is not limited by our design. It is not limited by our design. The solution that works best for the individual companies that this will get sold to will be able to implement these assets however their layout works. If they don't have a warehouse and they have one giant room with a bunch of shelves, they can implement it that way. Or if they have some crazy idea for how they want their sensors organized, they are able to implement it. Additionally, we have a Discover and Settings page set up. However, those 2 pages were not completed by the end of the project.
All right, so some issues and risks that we had in our project. So issue number 1 would be that the gateway is always listening all the time for any transmitting device in that LoRaWAN band, which I think is right around 890 megahertz. And since 890 megahertz is a lower frequency, those signals travel for quite a long distance, kind of how Taylor touched on earlier. You can have sensors that are in a warehouse a mile away, 2 miles away, and you can still pick up that signal. So you could have sensors or other traffic that's happening inside that band that's happening quite a distance away or maybe close by, and it could mess with your system. So that could be that's an issue that you could run into, and you could have some errors while using Angular material as well. So some risks that we had too were some security concerns with this project. This is an Oracle Linux box with root access to the network, so it could be potentially used as a pivot point to kind of exploit the network. And some things we could do to mitigate that risks would be to make sure the box is updated, to make sure to have strong passwords and to virtualize. So that was kind of some things we used for that.
So with our post-mortem summary, I mean, start with our improvements. We could easily have improved better, work more closely to the agile methodology. We tried to incorporate it more, but we kind of fell lax on that, and we definitely could improve that better. Then there's also, we could have also improved more by asking guidance more readily from our sponsors. Granted, that wasn't always the most response capable because of time differences, availability and stuff. So we wouldn't always be able to get a solution very quickly in some cases. Then also just having more generated completed solutions before we had our meetings with Inwerken. It would be better than just having, sometimes we'd have almost completed solutions but not completely there, and that's something we definitely could improve on.
So some successes we had. We had a lot of resources at our fingertips so that we could create a fully stacked solution, which helped us out because we had GitHub, we had languages that we could use for different things. And then we also had collaborated internationally, but doing this was a little tough because of time zones and documentation. And we also have solutions to support future sensors like the humidity sensor or the temperature sensor.
Next steps. So this, as you can see, the web page and the back end work well. The things that could be improved upon. Hardware itself, it can be increased. It can have increased storage. Currently, the Currently, the gateway is running at 97% storage capacity, and not everything is included in there, and that's only 2 sensors. But again, this is a prototype, so that's to be expected, and they are able to add onto that. Improve the sensors themselves. As you see, this is the only sensor we've got, and a 0 or 1 isn't the prettiest on a graph. They want to do things such as monitor humidity, monitor temperature, monitor ambient light for different reasons, for different solutions that are required by customers. Now, this requires actually having those sensors created and making sure that the data is stored in the right format and put in the right spot in these MQTT packets that get sent over to the broker. Discovery, making a dynamic discovery page. This was something that we didn't get to in the project. Deadlines came quick. Having a dynamic discovery page would use something like a WebSocket to connect to the broker itself and listen for all packets that are coming in and check the sensor against the ones that are currently in the database. So then it will be able to pop up with new ones that you buy or new ones that you are adding to your existing solution. By doing this, you currently the solution is it automatically adds new sensors because these sensors are proprietary. Reasonably, we can assume that the only sensors connecting to it are the ones that are supposed to. However, with a dynamic discovery page, you can make sure that the only sensors that are getting added to the database and are storing data are ones that you select. And also hardening the application. There's always room in any application for improving security. That's just the case. However, there are a couple areas in particular where our app could improve. This would be, one of these would be auth tokens, using authorization tokens and making sure that the different aspects of the pages are encrypted, in using encrypted methods to make sure that the information can't be sniffed, the passwords aren't listened in on, things like that. Also implementing users and different levels of users. Currently, the web page does not offer login services. However, implementing a login service and having different levels of access would make sure that a disgruntled employee or someone who is scanning your network and finds this web page doesn't go in and delete all your data. These are two big areas where our application could definitely improve on in terms of security. Questions from you guys?
You mentioned earlier that what's the frequency that sensors are transmitting data? Like
868.
So right now I pretty much can spoof that and just send a bunch of junk data. Is there a way to kind of add some sort of CRC checks?
You can spoof that and send junk data, but junk data isn't a JSON packet.
But what if I send the fake JSON packet? Is there a way to verify that?
It checks the JSON packet that it's in the structure it's supposed to be. You're going in there blindly. It's harder than cracking a password, figuring out this JSON packet is about 100 entries long.
Okay. So what if I do some sort of replay attack, something like that? I was just curious, how would you go about securing this? Is there sort of
It's IoT. It's insecure by design.
I wrote a paper on that. I was just wondering, how would you build on that to make sure that it doesn't happen?
It uses an MQTT broker, and that is basically a pub-sub method.
Yeah.
It's unsecure. Anything that publishes, anything is allowed to publish to it, and anything that subscribes to the channel will get anything that publishes to it.
Good answer. Thanks. Thank you.
So what do you think the most useful feedback to Inwerken was out of this?
I thought it was interesting working with a company that was foreign and not, domestic. a lot of the companies that were worked with were either in the U.S. somewhere or in the FM area. So I think that was a really interesting challenge. And I think that we learned a lot from doing that, like meeting with 7-hour time difference. So we were meeting at 9 a.m. every Monday, and that was towards the end of their day. So trying to like kind of parse that difference, and then also looking at documentation. So I guess my takeaway personally would be communication is really important, and making sure that we do that really well. And I think this was a good practice, I guess.
I think I had the question
Okay.
meant the other way around. Like you mentioned their gateway should have more memory.
Mm-hmm.
So I'm looking for what might be the most valuable thing you were able to pass to them.
I think that we provided a design direction, a really specific one, and that hopefully they can use this application as well to develop their product. I guess that would be what our value was that was passed to them.
That and a lot of like foundation research and experimentation that didn't completely go through all the way, or for example, like Node-RED. By last week, it was kind of decided like, yeah, we probably should just use Node.js from the beginning instead of actually using Node-RED. But we didn't know that at the beginning, and so we were developing our Node-RED, and then after a while, it's getting pretty big. So it's like, well, we're essentially creating a Node.js server. So we probably should have kind of started with Node.js, and maybe our solution would have been a little bit more slimmer in the long run. But that's what we came out with, just actually applying what they wanted us to do. So I mean. Any other questions?
Any questions? Yeah.
Oh. No? Okay, fine.
I think that's a question.
All right, thank
Cool.
you.
Thanks.